while we get the presentation, I will then give an introduction on why and how moss vegetation impacts ditches, and then you can write your questions in the chat, and then we will take questions to the two talks at the end of the session. Okay, I think it looks nice now. Yeah, full screen.
It's working.
I see it full screen. And next one, please. So this is what I just mentioned, and now we move on to a short introduction to ditches. Next one, please. So why should we care about ditches? These lands in landscape. There is a growing body of literature on ditches, but they, like you see from the graph, it's still other types of inland waters that are more intensively studied, such as streams, rivers, and lakes. And yet ditches have higher per area greenhouse gas emissions than other inland waters. And this is likely due to high nutrient inputs. So it's estimated that these ditch methane emissions make up to 3% of the total global anthropogenic methane emissions. And there are several key data gaps identified, such as ditch mapping, globally representative data, and ditch emission pathways. And we are going to talk about these using our case country, Finland. Next one, please. So, short introduction to Finnish peatlands. Now, I'm not sure if there is someone that is not based in Finland in the audience, but anyways, so the peatlands in Finland cover 30% of the land area and make up to 2/3 of the ecosystem carbon. And about half of them are drained. And unlike in many other European countries, most of the drained peatland is used for forestry. So this then makes it up to 17% of the total land area of the country that is drained for forestry. So it's not trivial whether these areas are greenhouse gas sinks or sources. Next one, please. And now, why should we care about these ditches? Next one. They cover only 3% of the land area in a peatland, but they can contribute up to 100% of the methane emissions. And this is because when the peatland is drained, the peat soil between the ditches can be efficient methane sink. So it's actually then the emissions from ditches that will impact whether drained peatland is a net methane sink or source. So that's why there is a need for a country like Finland to develop emission factors that reflect the national conditions and take into account then the conditions of the ditches and time since drainage and different features. And then another motivation for this study is that ditch network maintenance is changing along with the new schemes in peatland forest management. So ditch clearing is no longer subsidized, and then this continuous cover forestry is becoming more common. And with continuous cover forestry, you would need less of ditch clearing. Next one, please. So the first question is, how does vegetation impact ditch methane emissions? And the answer in brief is that when you have moss-free ditches, the methane emissions are an order of magnitude higher than from moss-covered ditches. This study is already published. This was led by Antti Rissanen. Next one, please. And the results were based on compiling methane measurements with the chambers from 21 forestry-drained peatlands. And then we found that the moss-free ditches, the emissions, annual emissions are quite comparable. What is the default emission factor currently used in the greenhouse gas inventory. But when you have these moss-dominated ditches, then the emissions are about 90% lower. And in the graphs to the left, you can see the moss-covered ditches in red. And in some parts of the summer, the ditch turns into methane sink. So it's uptaking atmospheric methane. Next one, please. And then the question is, why are the methane emissions lower in moss-covered ditches? There are some possible explanations. There can be, in the moss layer, then there can be methane oxidases, so that when the methane is produced in ditch sediment, it diffuses upwards. But the microbes in the moss layer are capturing it, turning it into CO2, and then the moss can photosynthesize that, and in this way the carbon from methane is incorporated in biomass and it never reaches the atmosphere. Then there can be kind of similar interaction between microbe and moss, more indirect. So moss photosynthesis is producing oxygen, and then it's released in the water, and there could be free flowing microbes that then are oxidizing the methane. Or then it can also be that these moss-growing ditches tend to be shallower, so the sediments are oxic more frequently. So we set out to study these different pathways. Next one, please. And this study was then conducted in 2 of those 21 peatland areas, and we measured methane fluxes and their isotopic signatures using chambers. Then we also studied bubbles, and then collected water samples, analyzed the methane concentration and the isotopic signature in water and then in gas from the sediment. And then the last part was to analyze this moss biomass. What is the carbon isotopic signature in that, and whether it's coming from methane or carbon dioxide. Next one, please. Here are just some pictures of the field work. So at the bottom in the center, you see the tube reaching out from the sediment. That's the sediment gas collector. And then the bottom to the right, there I'm installing one of those collectors in the ditch sediment. And then you see the bubble collector with the funnel. Next one, please. Now moving on to results. So first we looked at the isotopic evidence, and there we found that from the moss surface, the isotopic signature is enriched in C13, meaning that the light methane is used, presumably oxidized, while it's diffusing upwards. But we don't see the same pattern in the open water. So the moss is now on the column to the right, and then the open water values to the left. Next one. And then we also looked at the mixing ratios. And there it's really striking that the concentrations in the sediment are high. And when you move upward, they are about 4 orders lower in the water. So the sediment surface is very efficient in filtering methane, but there is still further filtering from the water to the air. Next one, please. The results so far, they were about diffusive fluxes, but then we also measured these bubbles, and it also seems that when you have moss-covered ditches, the bubble release is lower. Next one. And then, is methane a significant carbon source for sphagnum in ditches? So based on analyzing the water signature and the biomass signature, we could calculate that 10 to 28% of the carbon in sphagnum is potentially from oxidized methane. So it's quite a large share. Next one. So to summarize these results, so we have found that the methane emissions from moss-dominated ditches were 90% lower. Both moss layer and sediment surface are filtering methane emissions from ditches. The moss-dominated ditches can even be net sinks of atmospheric methane, and then quite large share of the sphagnum biomass carbon is potentially from oxidized methane. Next one. So what we can conclude for peatland forest management is that when you let the ditches overgrow by mosses, you can reduce methane emissions, and giving up ditch maintenance not only saves on cost, but it can also be additional greenhouse gas mitigation measure but of course you will also need some other measure to then attenuate the changes in soil water level in the peatland, and that way not reduce the risk of methane emissions, such as continuous cover forestry. Next one. And now these results show that the default emission factor overestimates methane emissions in Finnish forestry-drained peatlands. So when you have ditch type specific emission factors, it clearly improves the accuracy of ditch methane emission estimates. But to be able to use this new data, you would need to know what is the area of moss-covered ditches in Finland, and how would you even go about to calculate that. And now we will switch on to Leena's talk, and she will talk about her results on that. Thank you.
Thank you, Tuula. I will try to share my screen. Let's see how it goes. Does it look okay? Because to me it doesn't show anything.
We can see it.
You can see it?
Yes.
The presentation?
The presentation, yes.
Okay, perfect. So, good afternoon, everyone. My name is Leena Stenberg, and I'm a researcher at Luke in nutrient cycles and water loading group. And my background is in hydrology and engineering. And for the past years, I've been mainly working with modeling of drained peatland hydrology, forest growth, nutrient leaching, and also carbon balance. But let's continue to today's subject, which is predicting the moss coverage of peatland forest ditches in Finland. The main objective of this work is updating the methods for calculating peatland forest these methane emissions in greenhouse gas inventory in Finland, and so that we could use the new emission factors that Tuula was just talking about. And in my presentation, I will focus on the new method for estimating the share of moss-covered and moss-free ditches. So how can we classify the ditches? One solution was presented in the paper by Rissanen and others, where we created a random forest classifier for the ditches based on old forest inventory data. The data was a systematic subsample of the National Forest Inventory field plots on drained peatlands, the 7th National Forest Inventory. The measurements were from 1990 to 2013, that were used in the model development, and there were about 3,000 approved observations, of which almost half were moss covered. And there were data on ditches like ditch depth, ditch width, age, and other things, and factors that diminish ditch condition like sphagnum mosses, grasses and weeds, erosion, siltation, and logging residues on the ditch. And based on this data, we could make classification for 2 ditch classes, moss covered and moss free. Unfortunately, we were not able to use the grasses and weeds as one class because there were too little observations on those. We tested several different combinations of explanatory variables for the classifier, and it seemed that ditch age was the most important variable explaining the moss coverage. And for greenhouse gas inventory, we chose the classifier named RF25, which classifies the ditches in the moss free and moss covered and has explanatory variables, ditch age, north coordinate, elevation, temperature sum, and information about whether the site is nutrient poor or not. And class errors in this classifier were 12% for both classes, and there was overestimation of moss-covered ditches in southern Finland, about 2%, and underestimation of moss-covered ditches in north, about 3%. And we also made the first estimate of moss coverage of the peatland forest ditches for Finland for the year 2022 by applying the random forest classifier and spatial data. And the result was that there was 67% of the ditches that were moss covered. So this kind of indicated that with high moss coverage, the methane emissions would be clearly lower than currently estimated in the greenhouse gas inventory. But for the greenhouse gas inventory, moss coverage estimate for one single year is not enough, but we need a time series of moss coverage. So how to proceed for greenhouse gas inventory? So we chose to apply the classifier for the drained peatlands of the newest National Forest Inventory data. We assumed that for the classifying purposes, that data presents the whole inventory period from 1990 until today. But just to make sure, we also tested this assumption with older forest inventory data. But a problem still remained, how to estimate the ditch age, which was actually the most important variable explaining the moss coverage. The answer to our problem was found in forest drainage statistics. We have a long history of official data starting already from year 1909. The peak of first-time ditching was in the 60s and 70s, and the official statistics of the first-time ditching actually stopped at year 2000. And ditch cleaning data started in the statistics in 1965 and peaked in the 1990s. And nowadays it's quite scarce also. Ditch cleaning is done because the ditches get lower as time goes by. Basically, it means that digging the old ditches again, removing the mosses and other vegetation and sediments that may be filling the ditch. This is typically done a few decades after previous digging. Then from the statistics, we constructed time series of age distributions for the ditches. Basically, this was done using a simple bookkeeping for the ditches, but we had to make some assumptions. We assumed that ditch cleaning is made in 20 to 60-year-old ditches, which means that in a single year, we move the ditches from these age classes to the age class of 0 to 5 years, as much as there were cleaned kilometers during that year. And in addition, the statistics include also mineral soil forests, which we had to somehow take off from the records. So for this, we assumed that the share of peatland ditches followed the share of drained peatlands. So how to combine the ditch classification and statistics? We made the classification for all of the data points from the National Forest Inventory data using all age classes, and as a result, we get 0 or 1 for the moss cover of that point. Then we calculate the percentage of moss coverage in each age class and combine this with the information of the length of ditches in each age class. In the end, we obtain the length of moss-covered and moss-free ditches in each age class. And finally, by summing all the age classes together, we can get the share of moss-covered and moss-free ditches for the year of interest. These are the main results, which show that the share of moss-covered ditches is increasing. The explanation here is that since the ditch cleaning rates are declining, the ditches are getting older and the share of moss coverage is increasing. It seems that moss cover develops faster in the ditches in the southern Finland compared to north. And based on the random forest classifier, some ditches do not develop moss cover even at the old ages. And thus, the share of moss-covered ditches will most likely not reach 100% in the future, even though ditch cleaning would cease and the ditches would get older and older. And this is how the method affects methane emissions from peatland forest ditches. First, the application of the new Tier 2 level emission factors significantly reduce the methane emissions as expected. And secondly, as the ditches get older, because of the declining ditch cleaning rates, the share of moss-covered ditches increases, and as a result, methane emissions are showing decreasing trend with the new method. And this was actually the last slide. So thank you so much for your attention.
Thank you, Leena. We have one question. Now I'm not sure. Well, maybe both we will try to answer Sirpa's question. when a ditch was classified as moss covered, that is how large area of surface should be covered along the whole ditch. If I answer regarding the emissions, we were considering the well, not extrapolating to a whole ditch. It was like the spots where the chamber was. So it was either no moss or 100% moss. That was measured for that. But what about the upscaling, Leena?
Yeah, it actually depends on the old data and how they kind of thought about it. And we used, if there was this factors that diminished its condition, if mosses were mentioned there, then we assumed that the ditch was moss covered. And we don't actually know how largely it was moss covered, or so was there a lot of mosses or just a little bit. So it depends on how the people that made those measurements thought about it and how was it in the instructions maybe.
Thank you. Are the participants, can they have mics on, and now just we could open the floor? Or how is it, Maria? Is it via question writing in? Or?
Yes, we have to do it through the question and answers box.
Okay.
Please.
Okay, well, it seems that there might not be any more questions at the moment, but this was recorded. Maybe it will be a bit edited too, and then it will be, so there's opportunity to revisit. And if you then have questions, you can contact us. Oh, we have a question from Raisa. How your results will change greenhouse gas inventory in the future? Leena, would you like to start?
Well, at least the methane emissions will decrease from the ditches in the inventory. And well, how else? I may have to think about this a bit further.
Maybe I could add that I think there is now, this was one type of peatlands, forestry-drained peatlands. So now we would need to continue with refining for different types of land use in peatlands. We cannot really apply this for other types of land use. At least we would need to verify if it can be applied. Okay, a question about clear cuts by Alexi. How your results should be taken into account when implementing clear cuts? Does it matter what is the soil coverage? Well, let's say this part of the study is still in progress. So yes, clear ditches in the clear cut area were measured at one site only, and so far there's a large variation. It doesn't seem that the clear cuts would have like systematically higher emissions from ditches. At the beginning, I was kind of assuming that. I mentioned in in the very beginning of the presentation that there is a nutrient input to ditches, and this is why they might have higher emissions per area. So I was also assuming that this we would see at our clear-cut site, but maybe the variation is too large that it is masking like difference between the different age of peatland areas. Oh, what about the surfaces on clear cuts than ditches? Like other is this question about the emissions in the stripes in clear cuts? Do they act as a carbon sinks, and how does it vary? Is this what you mean? Like, yeah. This is an interesting question. Like now we talked about the ditches, but of course you would want to get an upscaled estimate for your peatland area, whether it is whatever forest management, is it clear cut or is it continuous cover forestry? And well, actually, I think maybe someone in the audience who has access to the eddy covariance data that is seeing a large footprint at the clear cut would have an answer to this. I think it's possible. At clear cuts, you usually have at least for early years higher water level. So I think it is possible that there are emissions from the areas between ditches, and some higher mounds can act as carbon sinks. But what is then the overall result for an area? This I don't know. We need to look into this. I would somehow assume it can overall be higher from clear cuts than from a forest area where the water level is deeper, but I don't have the data. Maybe there are no more questions, or are we now allowed to?
I see that Alexi.
Can we have Alexi?
Let's see. I see the button to allow
talk.
Let's see.
Yeah, if he would like to comment this clear-cut issue.
Now you can.
Yeah, sorry, I was kind of planning to press this other button, so it was an accident. But anyway, I would like to thank for the very nice presentation, interesting discussion. Thank you.
Thank you. Okay. Well, like I said, the recording will be available, so you can visit it. And well, large part of this work is still unpublished, but the publications are in progress, let's say. So those will be available a bit later then. Well, thank you very much, everyone, for participating our webinar, and there will be another HoliSoils webinar just in 2 days, so on Wednesday, and that will be then on, I think it was on microbes. Thank you.